Hello everyone, welcome to the first tutorial session of problem solving through programming in C. So this is a SWAYAM course which is floated by Professor Anupam Basu from Department of CSE IIT Kharagpur, and I am Siddhant. I am one of the TAs who will be uh, handling this tutorial sessions where we will solve some problems and related to the week's assignment and discuss the concepts a bit so that it will help you out while solving the assignments as well as in the final exam. Okay, so today I'll be covering only the week 1 content. Let me just a moment. Is there any some queries? Okay, none. Okay. All right. So let's start with this session. So first of all, let us break down the title. The title of this course is Problem Solving Through Programming in C. So the first term or the first few terms is problem solving. So problem solving basically can refer to any common mundane problem that we face in life every day. So when you think about solving any problem, how do you tackle it? You tackle it by thinking of the problem as a logical sequence. Okay, like let's say a common life problem would be, let's say I want to buy something from the market. Now if I want to buy something from the market, I have to first reach whatever shop it is in, I have to buy that stuff, and I have to return back. So there are, like, just oversimplification, there are three steps that need to be followed. So what I did just now is, the objective, I had a problem that I wanted to buy something from somewhere, and I broke it down to 3 different steps in a logical sequence, which is, first I somehow go to the market, I buy that stuff, I search for that stuff, I buy that stuff, and then I return back. So I break it down into a sequence which is logical, and this sequence can be, like, now there are different ways of solving this sequence, right? So when you think about similar problems from mathematics perspective, a lot of the problems can be again broken down into similar kind of sequences, and then you can solve each step of that sequence through programming. So programming, the second part of the title, programming in C. So programming is basically a tool. It can you can use this tool to achieve some particular purpose. In this case, we want to solve a problem using programming. Now if you are able to break down the problem into logical sequences, then you can just use programming, which is basically a tool, to solve each of the steps of that sequence one by one in the way that you have defined it. And that is how you use programming to solve problems, especially mathematical problems. Now C is a language, is one of many programming languages which are currently available, and it's quite a popular language that has been used since quite some time, more than 2 or 3 decades. So we'll be using the programming language C, and in this course we'll be looking at the different aspects of C, and we'll be trying to solve different mathematical problems, but the process remains the same. To solve any problem, we need to first break down the problem into logical sequences, and then we solve each of the steps of that sequence through programming. Okay, and this is why we need to, like, think logically. That is where the logical thinking comes in, so that you can break down any problem into simple steps which are in a logical sequence. And that is the most important part of the program, because programming is just a tool. Like I said earlier, you can learn to do programming, but this is something that you have to practice. When you are faced with a programming problem or any question in the assignments or in the final exam, you need to be able to break down that particular problem into simpler, smaller problems and solve it one by one, and that requires logical thinking. So that is the most important part. That is what we will try to imbibe in you through this course. Okay. Alright, so I think there is some kind of chat, something like that, no? Okay, cool. Alright, if anyone has any questions to ask, they can feel free to put it in the chat box or unmute and ask. Okay. Alright, now when we talk about logical thinking, a term naturally comes up in our mind, which is an algorithm. So an algorithm sounds like a pretty high-tech term, right? But it's nothing. What is an algorithm? An algorithm is basically a set of instructions to solve the problem. Now, earlier I told you that every problem, if you break it down into smaller bits and pieces, like smaller steps which are in a sequence, an algorithm basically is how you solve each of those steps. So an algorithm basically are instructions which will tell you how to solve each of those steps one by one in order to solve the overall problem. Now that is what makes the basis of this entire course. So every program that you write, it follows an algorithm. It follows a certain flow. There is a flow of instructions that you have. Okay. Now there are different ways of explaining an algorithm. So you could just write it in sentences. For example, you could basically write down a few sentences in English explaining an algorithm. That is one way. That is probably the simplest way of explaining. But then you have a bit more sophisticated ways, or a bit more well-defined, precise ways, like flowcharts and pseudocode. So flowcharts is what will be what has been covered in week 1. Pseudocode as well in very small aspects, but for now let's look at flowcharts. So in flowcharts, basically we represent all the instructions that we want to give to the computer in order to solve this particular problem in pictorial representation. So when you have a massive problem which has many aspects, many different steps to be followed, to simplify things, you could make a pictorial representation of the entire flow of instructions that need to be given to solve that particular problem, and that would be called a flowchart. That is how the instruction or the control of the program flows through, right? So now this is an example of a flowchart, and as well as a question that I wanted to. So in this session we'll be solving a few questions. Hopefully that will help you with solving the assignment questions as well. Alright, so as you can see, it's a pictorial representation. So this is a flowchart, and as you can see, it's a pictorial representation of the instructions that are given to solve the particular problem. We'll see what the problem is. Now there are a few rules to be followed. Like I said, it's a flowcharts and pseudocodes are more well-defined methods of explaining an algorithm. So when I say well-defined, there are certain rules that should be followed. So for example, you have this circle, like the circular box, which you can see has been used for start and stop. So this is basically used for start and stop, or for connectors as well, but we'll leave that be for now. Now you can see this oblong kind of box, right? This is an oblong box. This is used for input or output. Like you want to ask the user for some input, you use this. You want to print something, you want to give some output back to the user, you use this. Okay, so it's an oblong box. Now you can see this rectangular box. The rectangular box is basically for operations, like numerical operations, whatever kind of operations that you want to do. So all computational, whatever computational operations you want to do, addition, subtraction, division, and whatever else, all have to be represented in the rectangular box. So this is the rules that you have to follow while drawing a flowchart. So the start and stop of the program should have a circular box. Next, you use an oblong box for input or output, and whatever else the computational operations like numeric operations, addition, subtraction, all the arithmetic operations and so on are rectangular box. Then you have a rhombus. You have rhombus, and rhombus is for decision making. Okay, decision making operations. So let's say I want to say that if I have a variable something a, I have a, if a is less than 7, then I want that a should be incremented by 1. Okay, if not, if a is not 7, that is else a should be decremented by 1. Say I want to write this. Okay, so I will just put a rhombus, like there would be definitely something before this. I would put a rhombus. I would say a is less than 7. I'll put this. Then there will be a yes branch, and then there will be a no branch. Okay, and they will be separate. So here I will have a is equal to a plus 1, because that is what I have to do when a is less than 7, and in the no branch I will have a is equal to a minus 1. Okay, so these are some of the different rules that you have to follow while making a flowchart. Now let us see what the output of this particular flowchart will be. So we start the flowchart, we read the numbers x equals 10, so we have some number x and we are saying that the value is read as 10. Now in the next box we are saying that there is some number y, and that has the same value as x has, that means it has the value of 10. And in the next box we are saying that y equals x by y plus 2y. Now when you say x by y, x is already 10, y is already 10, and 2 into y, y is 10. So what do you have here? You have 21, right? 20 plus 1. So you have 21, and y, that this 21, now that means the number y is 21. Now in the next box what you do is you print y, and then the program stops. So when you print y, so what this overall program does is it takes a number which is x with the value of 10, then there is y, the variable y, which takes the value of the variable x, and then you do some more operation, division, addition, multiplication, whatever, and you save that value in y again, and here this value of y, whatever has been allotted in the previous box, is going to be used here. As you can see, the flow of the program, the arrow that you can see, that is the flow of the program. Okay, and once y has been computed from this box, it goes and it prints y, and as we can see, the value of y is 21. So for this case the value is 21. Is that clear?
Excuse me, actually I have a doubt here.
Yeah.
Actually, for the input and output we are using actually parallelogram shape boxes.
Okay, yeah, so there are a few, like depending on different books that you follow, there can be different approaches. So yes, in some books you you will see that input output will have parallelogram boxes instead of oblong, but it's fine. I mean, just stick to one of the two nomenclatures. In this particular course, the faculty has used oblong box for input and output, but yes, you can use, in some books I have seen, you can use parallelogram boxes for input output as well. Okay, so it's okay, just follow any one of the, like, stick to any one of the rules. Okay.
Okay.
Okay, yeah. So anyone else has anything to ask? All right, so let's move on to the next slide.
Actually, I have a doubt. Previous slide.
Yeah.
Third slide. Actually, this question is already there in that assignment question.
Mm-hmm.
There it's x is equals to 1. Actually, the question is that it's a compilation error. It is mentioned in that question. The
Mm-hmm.
answer will be compilation error.
It's in the
Actually, some are discussing that how can it be a compilation error when it's an algorithm. It's not getting we are not giving it to a computer. How it's
mm-hmm.
a compilation error.
Well, it's in the current assignment, so I am not at liberty to discuss that. Um, but yeah, I mean, probably in the next class I can shed some light on it, or if there is a mistake in the question, then you will get to know that as well. Like, there will be a mail from NPTEL regarding that if the question is wrong itself. Okay. Um, if not, then yeah, we'll see in the next class. So yeah, I'm sorry, but I cannot, because it's in the current assignment, I'm not at
It's okay,
liberty
sir.
to answer that. Okay. All right, so let's see the next question. So now we have a bit more complicated flowchart, as you can see, and you have this decision making box here, which is a rhombus, like I was explaining earlier. So let us see what happens, like what is the print value of y once this flowchart is executed. Okay, so we take x as an integer, which is x is 1248. Okay, that is what, when we read x, that is what we read in this step. Now, and we set y equals 0, so variable y is 0, and then we start this particular decision making loop. So what happens in the first loop? Okay, I'm talking about the first loop, that is this entire portion. I'm calling it a loop because it will run again and again. Probably we'll see if it runs again and again or it runs only once, but it will run at least once because this is getting evaluated at the end, right? So for now, here you can see the arrow is pointed towards this, so the flow of the program cannot go in this direction, it cannot go in this direction. Okay, this is not possible, so it can only go in this direction. Now what happens here is y is 0, so when I compute this particular statement, is 0 into 10 plus x percentage 10. Okay, so you have 1248 percentage 10. So what does percentage do? Percentage is called the remainder function. Okay, remainder, or not function, rather remainder operation. That means it will give you, if 1248 is divided by 10, then what will be the remainder? That is what this particular part will give you, and as you can see, the remainder will be 8, right? Because it will be 124, the quotient will be 124 and the remainder will be 8. Alright, so here the value of y becomes 8. Now in the next step, x equals x by 10. So x is 1248 as we know it, and we divide it by 10, so the value is 124. 124.8, you can consider it as 124.8 as well, doesn't matter, but here I'll just consider it to be an integer because x is an integer. So because it's an integer, it cannot have digits after the decimal. Okay, so 124. Alright, now we check, is x equals 0? Is that so? No, right? It's not 0, it's 124. So we go back, we start again from this statement, right? And that becomes our second loop. And the second loop, what happens is y is now 8, right? So you have 8 into 10 plus you have x 124 percentage 10. So how much is this? This is 4, right? So you have 84. So far so good. Now x is 124, we divide it by 10, now it will be 12, because again it is an integer. So then we check, is x equals 0? No, it's still not 0. So we go for the third loop. Now in the third loop, what happens? Again we calculate the same thing. We have y as 84, so 84 into 10 plus now x is 12, so 12 percentage 10, this will be 2, so you have 842, and then x equals 12, you divide it by 10, you will get 1. Okay, now you check, is x equals 0? No, it's not. X equals 1, so it's still not 0. So we go for the fourth loop. In the fourth loop, what happens is y is 842, so 842 into 10 plus now x is 1 percentage 10, so this is what? I mean what will be the remainder here if you calculate this? As, it will be 1, right? Because I mean the quotient will be 0. Like ideally, if you divide 1 by 10, what should it be? It should be 0.1, right? So the quotient is 0, the remainder is 1, so this will still be 1, and this will be 8421. Now x is 1 divided by 10, and this will become 0 because it's an integer. It's 0.1, the digits after the decimal is ignored, so you have x equals 0. Now x equals 0, when this condition is evaluated, that is x equals 0, yes, it's equals 0. So now the flow of the program comes in this direction, okay, and it prints y. And what is the value of y then? The value of y is 8421, right? This is what is the value of y. This is what is going to be printed, and then the program stops. So here the correct answer is 8421. And what exactly does this program do? If you see x and you see y, what do you can you tell me what this program, this flowchart basically gives you the algorithm for? It gives you the algorithm for reverse of the number, or let me write reverse of the integer, right? This is the algorithm for reverse of the integer. So you entered an integer which was 1248, and you get the exact reverse of the integer as the output. So this is the algorithm, this flowchart is the algorithm for calculating the reverse of an integer. Okay, does anyone have any doubts? Okay, so which part are you having issues with? Sorry? Okay, fine. I'll cover this through again. So first you read x is 1248, that is the integer. Okay, then you set y equals 0. Y is another variable, we set it to 0. Now in the first loop, what we do, the first time that we execute this statement, what we do is y equals y into 10 plus x percentage 10. So what percentage does is, percentage is the remainder operation. So basically 1248 percentage 10 means when you divide 1248 by 10, what will be the remainder? So here 124 will be the quotient and 8 will be the remainder, right? So this will evaluate to 8, and y is 0 here, so 0 into 10 is 0, so plus 8, so y becomes 8. Alright, now x equals x by 10, so x currently is 1248, you divide it by 10, and because it's an integer, so it cannot have any digits after the decimal, so it will be simply 124. Now we check after this the next statement is this rhombus, which is x equals 0? No, it is not equal to 0, it's equal to 124. So then we go to the no branch, because this condition it's not satisfied, so we go towards the no branch. The no branch takes us to this point again, right? It takes us to this point, and we again evaluate this statement and this statement, and again we check the condition. So here the second loop starts. So y is currently 8 because it became so in the previous loop. So 8 into 10 plus x is now 124, so 124 percentage 10, so that evaluates to 84. Next you have x equals 124, which is x equals 124 divided by 10. Now that is 12, x being an integer. Again you check, is x equals 0? No, it is still not 0, so you again go back and do this again. So however, now y is 84, so 84 into 10 plus x is 12 percentage 10. Now you get remainder of 2 here, so 840 plus 2, 842. Now x is 12, so 12 by 10, it's 1. Now you check again, is x equals 0? No, it is not equal to 0, it's equal to 1. So again you go through the no path, you reach at this point, and again start evaluating this. So y is 842 multiplied by 10 plus x percentage 10, x is 1 percentage 10, that means you are dividing with 10, 0 is the quotient, 1 is the remainder. So you have 8421, and then you divide x by 10, that will become 0.1. 0.1 is dropped because it's an integer. Now when you check x equals 0, it is equal to 0, so you go through the yes route now, and then you print y, and y at that point is 8421. Okay, so this entire program, it gives you the algorithm for reversing the integer. Alright, then we can proceed to the next question. So this is a much more simpler question. So here another flowchart. So we read two numbers, a equals 3 and b equals 2. Now after reading that, we do this computation, which is b equals a plus b. Now I am saying that b is equal to a plus b, so a is 3, b is 2, so now b becomes 5, but a is still 3. Okay, now in the next statement what happens is b is equal to a into b. So what is a? A is still 3. Now what is b? B has become 5, then plus b by 5, so b is 5 again divided by 5. Okay, so this is 15, this is 1, so total of 16. Now it prints b, in the next time it prints b, and then stop. Okay, so here the output of this code will be 16. Is it clear? Alright, yeah, this was much simpler than the previous question. And here, okay, so here we have another one with the decision making statement. So try to solve this problem by yourself if you are able to answer this. Let's see if you are able to answer this. You can put the answer in the chat box. So you have sum to be 0, n to be 0. These are the two variables initially. Then what you do is you calculate, you do n is equal to n plus 1. So I write first loop. First loop, what happens? N equal to 0 plus 1, that is 1. Now what happens to sum? Sum equals sum plus n. Sum is 0. So you add 1 with it. So it becomes 1. Now you check, is n equals 7? N equals 7? No, it is not equal to 7. So it goes to the n root and it does n is equal to n plus 1 again. So I would say second loop. So n is already 1. Okay, now it adds 1 again. So it becomes 2. Now what happens to sum? Sum is 1 earlier. Now it adds with n. N is 2. So sum becomes 3. Now is n 7? No. So third loop. So n is now 2 plus 1 becomes 3. Okay. Now sum is 3. You can see from here sum was 3, and now you add it with n, so it becomes 6. Now you check, is n equals 7? Still no, it's 3, it's not 7. So we go to the fourth loop. You again increment the value of n by 1, it becomes 4. Now you say sum equals 6 plus, that is sum, the sum value was 6, and then plus n, which is 4, so it becomes 10. Now n, again you ask the question, is n equal to 7? And still no. So then we go to the fifth loop. We get n equals n plus 1, which is 5, n becomes 5. Then you have sum, which is at 10. In the previous loop you can see it was 10 here, then plus n, which brings the value of sum to 15. Now you check, is n 7? No, it is not 7. Then we again go to the no root, to the n equal to n plus 1. Now sixth loop. So n was 5, we incremented it to 6. Now sum was 15, we added 6 with it, it became 21. We again checked, is n equals 7? No, it's not, it's equal to 6. So we go to the seventh loop. Now n here was already 6, it became 7 now. So sum was at 21, we add n, it becomes 28, right? And then we check, is n equals 7? Yes, here it is 7. So now finally we come through the yes root and the loop exits. So we go to the next statement, which is the print sum. So now if you print sum, you will get 28 being printed, right? And then the program stops. So here the answer here will be 28. Is it clear?
Yes.
Okay. Alright, so if there are no questions, then I'll move to the next slide. So again, to a bit of theory. So these are the principal components of a computer. You have some input devices. You can say there is mouse, there is keyboard and stuff here, like through which you can give data to the computer. Then that data goes to the central processing unit, which consists of the ALU and the CU. This is the arithmetic and logic unit and the control unit. So all the arithmetic operations and logical operations happen in the ALU, and the control unit basically helps in keeping the operating system going and for connecting the different systems or different processing units. Like it is responsible, all the data passes through the control unit to the other units. Okay, so it is in charge, it is like the brain, it is in charge of everything else. Okay, but the computations occur in the arithmetic and logic unit, which is called ALU. And then the CPU, the central processing unit, also gives and receives data from the main or internal memory. So this we call it RAM. You might have heard that, like, my system has 8 GB RAM, 16 GB RAM, 4 GB RAM, and so on. So this is the random access memory. So that is the internal memory of the device. And if the central processing unit wants to temporarily save some kind of data for further processing, only for temporary saving, so it will save it in this internal memory and it will later use it. Okay, now once the entire processing part is done, the data, the output, will be sent to the output devices. So this is basically, it can be your monitor or printer or whatever, all kinds of output devices. Okay, so this is like a very brief outline of the components of a computer. Alright, now next is the number systems. So there are different number systems. As you can see, that this is not a programming concept, rather it's a mathematical concept. So depending on the base that you select, you can define number system. So if it is a number system of base 2, you will have the digits 0 and 1. If it is the base 8, so you can define digits all the way from 0 to 7. If it's a base 10, like our decimal system, you have digits all the way from 0 to 9. If it's a hexadecimal system, which is base 16, you have digits from 0 to 9, and then instead of digits we write letters. So A basically means 10, B means 11, C means 12, 13, 14, and 15. So it's just a difference in notation. Okay, so but if you see, the numbers go from 0 till 15 in a way. Now the reason why we need like higher base systems, so that when you're working with very large numbers, like think about like hundreds and hundreds of digits, okay, numbers going to some trillions and beyond, trillions of whatever. Okay, so then if you have a higher base system, you can write it in a more compact manner. Okay, so that is the advantage of using higher base systems. So that is why this higher base systems had been developed. So this hexadecimal system especially has been developed because of that. And you have this binary system. So this is the one that is machine readable. Okay, so this is the simplest base system that you can have. This is base 2, which has only 2 digits, 0 and 1, and this is the one which can be understood by the computers. Okay, directly. But we usually tend to use the decimal system, and that has to be converted to the binary system every time we use it. For the computer to understand it, it has to convert the decimal to binary. So let us see an example of how to do that and how to do the reverse. So here I have an example. This is the number of base 2. So you can represent the base in this format. So it is 1011.101, all in base 2 now, and we need to convert it to base 10. So what is the procedure to do that? So you have this. So the way to convert from binary to decimal is as follows. So you have to multiply all of this with some certain values. Okay, I'll tell you what exactly. So this you will multiply with 2 to the power 0, this you multiply by 2 to the power 1, this with 2 to the power 2, this with 2 to the power 3. So you start from the digit before the decimal point. You start multiplying 2 to the power 0 and with increasing powers. So increasing powers of 2. So 2 to the power 0, 1, 2, 3, and after the decimal you multiply it with negative powers. Okay, then after multiplying all of this, you add all of them up. Okay, so basically this will be 2 to the power 0, it will be 1, Next, this will be 2, this will be 0, this will be 8, and this will be point 0.5, right? And this will be 0.125, right? I mean, this will be 0 and this will be 0.125. So you can calculate how much this comes out to be. You can get some 11.625 or something, right? So this is of base 10. So this is the decimal equivalent for this particular binary number. Alright, now if you wanted to convert the decimal to binary, what you would have done is you would have divided it by 2. Like here you multiplied it by 2, so there you divide it by powers by 2. Keep on dividing by 2 and take it in the opposite fashion. So I have, let's say, this number. I have okay, just a moment. Yeah. Alright, so let's say I have a number 65 and I want to convert it to binary. So I just keep dividing it. So this is how much? This is 32 with a remainder of 1. Again 16, remainder of 0. 8, remainder of 0. 4, remainder of 0. 2, remainder of 0. 1, remainder of 0. 0, remainder of 1, and then you take just the opposite in the opposite manner. So 65 in decimal system would be 1 0 0 0 0 0. So 5 zeros, yes, and then 1, and this would be the binary equivalent for this particular number, for this particular decimal number. Similarly, when you come to hexadecimal, what do? So the way to convert hexadecimal to binary to decimal is similar. So you have base 10, right? Base 16, right? So you multiply it. You multiply it with what? Multiply it with 16 to the power 0, 16 to the power 1, 16 to the power 2, 16 to the power 3. And then you add all of them up. So this will be 6 into 16 to the power 3 plus a. What is a? A is 10. So 10 into 16 to the power 2 plus 7 into 16 plus f is 15. So 15 into 1. So whatever you get here is the decimal equivalent for this particular hexadecimal number, and you will see that it's a larger number. The number will be a bit larger, okay, and you can see how compactly we have written this using the hexadecimal notation. Okay, so these are the different number systems that are there. Later on in the course we will see questions where the input or the variable has been defined with hexadecimal, with octal, with binary, in different ways. We'll see them as I think in later weeks, somewhere around week 4 or 5, I guess. But we'll look at a few examples of that. Okay. Alright, so now let's briefly talk about programming languages. So programming language, like I said, it's just a tool. It's a tool to convey the instructions, that is the algorithm, to the computer. So we have basically the set of instructions which we know as algorithm. Now we want to tell the computer the algorithm. So the programming language is the tool that we use for telling the computer what algorithm we want to use. And there are basically 3 levels of languages, or rather I would say these are the 2 important levels of languages that we should be concerned with. So there is the machine level language and the high level language. So machine level is in binary, okay. So it is something that can be understood by the computer directly, and usually it has been compiled or interpreted. I'll tell what exactly that is. So this is basically the machine level language is basically binary code which can be directly understood by the system. Now a high level language is basically the source code or the language in the form that we will be writing. That is a high level language, and that in order for the system, for the computer to understand the code, it needs to be converted to the binary format. Okay, and that is done by a compiler or an interpreter. It converts this source code, which is the program that we write. Okay, this is the program that we write, which is the source code, and the compiler or the interpreter converts it to the machine level form. And the difference between the compiler and the interpreter is that the compiler converts entire program at once. Okay, while an interpreter converts it line by line. As we keep writing, it converts it line by line. So C, as we know it, uses compiler, but there are many programming languages that use interpreter. For example, Python has an interpreter, not a compiler, while C, C++ uses compilers for this. Okay, and then you have the assembly level language, which is kind of a middle ground, but more towards the machine. It is a bit more biased towards the machine level. So it allows you a lot of functionality with respect to, like, if there is some programming that you have to do where you have to manipulate hardware directly, you have to connect to hardware directly. So it is usually used, the assembly level languages, but these days you have many other languages which are slowly replacing assembly level languages. For example, you have embedded C, which helps you directly coordinate with the hardware, directly work with the hardware, instead of because in a way assembly level language is actually quite difficult. It is difficult to understand and to write code in assembly level languages. So slowly it is getting outdated and is being replaced by other languages which are much easier to write but still allows us to access the hardware. Okay. Alright, so the next thing is about memory and about variables. So there are, as we saw in the previous one of the diagrams, that we are talking about this primary memory, and I said that the RAM comes under the primary memory. So similarly, there is the secondary memory. Usually you have the ROM and whatever the hard disks and everything. This would come in the secondary memory because it's more of a permanent storage compared to the primary memory. The primary memory is volatile. That means if you turn off the computer, poof, the information is gone in the primary memory, but in the secondary memory the information still stays. So it is a more permanent storage compared to primary memory. And then you have other memories such as the cache, registers, buffers, and so on. So you have L1 cache, L2 cache, maybe L3 cache, depending on the machine that you have. So these are very fast memory registers, and you don't need to be really concerned with them. They work on an operating system level. And they are a relatively more modern kind of memory compared to primary and secondary memory. Primary and secondary memory have been there since the very first computer, but this have been more recent and comparatively more recent additions, right? Alright, now when you talk about memory, so we talk about this bytes and about bits. So 1 byte is 8 bits. Bit is the smallest unit of memory. Like we cannot define a memory unit smaller than a bit, and 8 of those bits form 1 byte, and then you have 1024 of bytes forming 1 kilobyte, then megabyte again 1024 kilobyte forming 1 megabyte, and so on. like you would see that like files these days, even the photos that we take from our phones are in some MBs, right? So those are like megabytes. That means that is 10 to the power 6, order of 10 to the power 6 bytes. So that is, if you think about it, it's a lot of memory. So it's good to remember that. And this concept, this 8 bits, will come a bit later, when probably in the next week, when we talk about how variables are defined. So whenever we define a variable, it has 8 memory spaces basically, I would say. So it defines it with respect to 1 byte. So 1 byte is the minimum that you can allot to a variable, which is basically, you will see later that one character, one keystroke, one character is 1 byte, and 1 byte will have, okay, one more, yeah, will have 8 bits, so 8 memory spaces. So how they will be converted, like the character will be converted to binary, and it will be stored in this, among this 8 memory spaces, right? So each of this is 1 bit. This constitutes 1 bit, and you have like 8 bits like that, which constitutes total of 1 byte. Okay, now the next thing, that what is a variable? So variable is basically a memory location. So you have this huge RAM somewhere in your system. This is the entire RAM. Out of that, the variable, say, is a small memory location somewhere in the RAM, during which your data is stored, which is allocated to your program, and the data is stored and used during your program run. Okay, so the variable gets allocated during compilation, the memory location gets allocated to your program during compilation, and then you do whatever you want to store, whatever value during the running of the program. You can store it in this variable, in this memory location, and you can use it, you can access it, you can use it, and then at the end of the program it gets deleted. The memory location gets freed, the variable gets deleted after the end of the program. Okay, now when I say y equals or x equals y, what does that mean? So basically, you have inside the program, when you write this kind of statement, so there is a memory location for some x, and there is some memory location for some y. So both are variables, there are some memory locations. So there was some kind of values here in y, and when I write y equals x, it copies the value of y to the memory location of x. It goes to the memory location of y, copies the value that was there in the memory location of y to the memory location of x, so it makes a copy. Okay, now what happens when I write x equals y into z? So in that case, say you have some x, you have some y, and you have some z. Now it will access the memory location y, it will take the value of this, it will access the memory location of z, it will take the value of this, it will send it to the ALU. The ALU will do a multiplication operation, which is x into z, with the values of obtained from the memory location of y and memory location of z. So it will do this multiplication, and this value it will store it in the memory location of x. Okay, so that is what happens when I write x equals y into z. Okay, so that is what happens in the background. Is that clear?
Yes.
Sorry, the last 2 points. Okay, so when you say that x equals y, what happens is there are two memory locations, which is x and y in the memory, in the RAM, and so the program goes to the memory location that is y, it sees the value in y, so there is this value in y, and then it copies that value to the memory location of x. So that is what is happening when I write x equals y. This is what happens, it copies the value of y, or the value that is stored in the memory location of y, to the memory location of x. So that is what happens when I write x equal to y. Now what happens when I write x equals y into z? So there is these three variables which have been allotted some kind of memory location in the RAM. Okay. Now what happens is I access, or the program accesses, the memory location y. It takes the value from there. It accesses the memory location z. It takes the value from there. It sends the two values of y and z to the ALU, that is the arithmetic and logic unit of the CPU, where the arithmetic and logic unit computes y multiplied by z. So that computation is done in the ALU, and the ALU returns that value and saves the value in the memory location that is allotted to the variable x. Okay, so this is what happens when I write x equals y into z. Is that clear now?
Yes.
Yeah.
I have a doubt actually.
Yes.
When you said that the y value will go to ALU and z value also go to ALU.
Yes.
Who controls this flow? It go to
Yeah, so that actually goes through the CU. That is what the control unit does. So the control unit is in charge of all these flows that occurs from the ALU, from the so in a way it will be like you have this RAM, okay, and you saw that it was written the CPU, right? Like something like this, the CPU was written, and part of it was ALU, part of it was CU, right? Now there was a give and take of information. So what happens here is that this y and z goes from the RAM to the CU, through the CU to the ALU. Okay, so y and z will go through the, okay, let me just redraw this. Yeah, okay, right. So this will go through CU to ALU, like this y and z, and then it will be computed here, and then it will again come through the ALU and CU to the RAM. This will be x. Now it will be stored in x. Okay, this will be, the value itself will be y into z. So all this control is handled by the control unit. The flow entirely is handled by the control unit, which will send what data where is controlled by the control unit. Is that clear?
yes, it's
Yeah.
and if we have to print it, then it has to flow through C again.
Yes, and the CU will send it to the it will go through the CU to the output device. Yeah. Yeah. All right. Now this is the last slide I have for today. Yeah. All right. So this is quite easy if you have followed some of the previous flowcharts that we were looking at. So the question is, draw a flowchart to find the sum of digits from a natural number n. So we have, okay, of a natural number n. So we have a natural number sum n. Let me say it's 1, 2, 3, 4. Okay. Now we need to draw a flowchart to find the sum of the digits of this particular natural number. So it's like a combination of the two flowcharts that I showed earlier in the previous slides. So how do we go about? So we need to extract each of these digits of the natural number. So we saw a program or a algorithm earlier how to calculate the reverse of a number. So this will follow a similar kind of approach. So we will first start the program, which then what we will do, we will read n. Okay. Now after reading n, what do? We go into defining this sum. Like we say sum equals 0. So this sum will store our sum of digits. Okay. Now after that, what we do, we check. Okay, here what I will do is I will go ahead and put the decision statement at the very front. So I'll say if n is 0, okay, I'll ask if n is 0. So this is a decision statement. I've put it at the very front. Now if n is 0, then it will simply, for the yes, it will simply print sum. Okay, this should be oblong. It should be printing sum. Okay, now if it is no, then what do we do? So okay, so this is the flow control, this is the flow control. Okay, now the first thing that we do, let's say we calculate, let's say sum equals sum plus n percentage 10. So n percentage 10 gives us the last digit, which will be the remainder when we divide it by 10. So we do this. After this, what do we do? We divide n by 10, right? If you remember what happened in the reverse of the integer program. So we divide n by 10, and then what? So we are done here for this particular loop. We go and we join back here. Alright, and once this is done, just print stop. Is this flowchart understandable to you? Okay, so let's say what happens, let's go from the beginning. So we read n, say I read n, it is 1 2 3 4. Now I set sum equals 0, I set sum to 0. Now let's look at the loops. The first loop, I check n equals 0. Does n equal 0? No, it does not equal 0, so we'll go here. So now sum, the first thing that I do is sum equals sum plus n percentage 10. So sum is 0 plus n percentage 10. N is 1 2 3 4 percentage 10. So this is 4. So 0 plus 4 is 4. Now n is a natural number, so it cannot have any digits after the decimal. So n was 1 2 3 4. We divide it by 10. So what happens to that? It becomes 123. Okay. Now we check again, is n 0? No, it's not 0. So we start the second loop. So we say sum, now again we do this, sum equals what? 4. Sum was 4 here. So 4 plus n percentage 10. So n is what? 123 percentage 10. So what is that? That is 3, right? So 4 plus 3 is 7. So far so good. So now again what we do, n was 123, we have to divide it by 10, n equals n by 10, so that becomes 12, n becomes 12. Now after this we go back here again, we ask, is n 0? No, it's not 0, right? So we again go to the no route and we start the third loop. In the third loop what we have is sum is already 7, as you can see here, then plus n percentage 10. N was 12, right? So n percentage 10, so this will come out to be 2, right? So 7 plus 2, 9. So after doing that, n equals n by 10, so 12 by 10, this will give us 1, because the decimal part is to be ignored. It's a natural number, so the decimal part will be ignored. So n equals 1. Now we ask again, is n 0? No, it's not 0, it is 1. So we go to the fourth loop. We say sum equals sum plus n percentage 10. So sum is 9. Now n is 1 percentage 10. And what is 1 percentage 10? It is 1, because the quotient will be 0 and the remainder itself will be 1. So 9 plus 1, 10. And then n equals 1 by 10, which is 0.1, but 0.1 is dropped because it's a natural number, so n becomes 0. It's no more a natural number. So now we check n equals 0. Yes, it is now 0. Okay, so n becomes 0. So next, so we move to the yes root here, and what does that do? It prints the sum. So what is the sum now? The sum is 10. So it prints 10. So that is the sum of the digits, right? 1 plus 2 plus 3 plus 4. So what I did is I extracted one by one the digits starting from the end. I started extracting, first I extracted 4, then 3, then 2, then 1, and I kept adding in each time I kept adding up, and I ended up with the sum of the digits. Is it clearer now?
Yes.
Alright, so this is all that I had for you for the material concerning week 1. If you have any doubts, you can ask me right now, or we
And show first and second.
first and second slide.
Re-show.
Okay, so are you able to see the second slide?
Yes.
Yeah. Okay. So anyway, I'll be sharing the slides and the recording as well. You will find it in the NPTEL in the SWAYAM website where you have registered. You will find where you find the week's lectures like week 0, week 1, week 2, and so on. You will find a problem solving sessions, another entry there called problem solving sessions. There you can find a link which will give you the links for this particular presentation, as well as for the recording. So it will be uploaded in a few days. So all of this will be shared with you. All of the slides and the recording will be shared with you. Okay. Okay. If there is no doubt, then we can probably end the session here. No, this is just once a week. So for yes, every Tuesday 6 to 8 is supposed to be the slot for this particular class. Yes.
Sir, is the link same, sir?
Yes, the link will be the same every time. Yeah.
I have a doubt, sir. Actually, I don't have any much knowledge about coding.
Yes, this is a very introductory level course for C programming. So if you want to just learn like if you want to learn C programming from the very basics, this course is good for you. So you can do this course definitely. Yeah. Okay. All right then. We'll meet. Um, we'll meet again next Tuesday, 6 to 8, for discussing some problems from week 2. So meanwhile, if you have any queries, you can put it on the forum in the SWAYAM website as well. Yeah. Thank you for joining.